Alright, so today we're going to be doing some integration of some, we call it the disk method or the washer method. And the idea is a function that looks something like this, whatever. This is some f of x. We're going to integrate it from, let's say, a to b. And we're going to wrap that sucker around, let's say in this case, the x-axis. So if you spin it around, look down the business end of it, you'll see a circle. So what we're going to be doing is cutting disks basically off of them. Disks that are a dx wide. And so then each one of those will be a little disk cylinder. It'll have a radius, which is your f of x. Okay. And so as you know, it's pi r squared times the height. So for our formula, it'll just be pi f of x squared dx from a to b. And the a to b dx bit is the height that we're talking about. Okay, so it's a very straightforward process. So, well, what if it's this formula, Mr. Room? What if it's x squared plus 1 from 0 to 4? Okay. Hey, that's key. Okay, so if you look at it, you're going to have like this. And that's going to be some sort of a deal. That's what you're cutting off, these little discs, basically, right? These ideas, they're very small, thin discs. But to do this, it's simply going to be pi x squared plus 1 squared dx from 0 to 4. So, of course, that's x to the 4th plus 2x squared. I'm just foiling, that's all. That's all, yo. X to the 5 over 5 plus 2x cubed over 3 plus x from, whatever, 0 to 4. Of course, 0 on the bottom end. 1024 over 5, which is about 200. Well, it's not about 200, stupid. It's 205, I think. Oh, it's 1024. Sorry, that doesn't work. It's 200. 204.8, I guess, if you want to get tricky about it, huh? 125. Oh, what are you doing? 64, 128 over 3. And so you're playing along at home. That's it's 40. What, 42.66666 or some such. Plus faux. So 246, 247.4, 251.4 pi or something. Whatevs. But the big deal here is it's units cubed, of course. Okay. So we're going to be doing a bunch of these. You'll get the hang of it. Whatever. Use your calculator. It's too late to open a calculator. I don't care right now. All right. So here's another one. Oh, not that. Stupid. Here's a function. I feel like I'm talking louder than normal today. Whatever. And let's don't do that one. Let's do this one. Let's do cosine of x minus 1 plus 7. Hey, that's cute. And let's go from 0 to, I don't know, 3. No, 3, jackass. 7. There it is. Okay, 0 to 7. So we're going to wrap that sucker around there. Something like this. Wee. Well, you get the picture. And so we're chopping it thusly, again, in the dx fashion. So it's pi, 0 to 7, cosine x minus 1 plus 7 squared dx. Now, how would I attack this, Mr. Grimm? Well, I'd FOIL it. The day that it does, may we all. All right. Okay, this part here is easy. Any idiot can do that. What is it going to be? So 14 cosine x minus 1. Of course, if you're doing it, that's your u. du is just your dx. Ain't no thing. Whatevs. This is 49 over x. Now, this one here is gross. A lot of you messed this up on the last test. Remember, cosine squared. So 2 cosine squared minus 1 is equal to the cosine of 2x. Hey, that's cool. Well, I have the cosine of x squared minus 1 like that, like so. So that's equal to a half cosine of 2x minus 1 minus, or plus rather, a half, right? And if you integrate this sucker, you're going to get something like, again, if you let that be your u, so u equals 2x minus 2, then du, of course, is 2 dx. Well, I don't have a 2 dx. I have a half of a du. So I'm actually going to get a quarter sine 2x minus 1. You can FOIL it out if you like, make it 2x minus 2, but whatevs. And then you get that. Quarter sine 2x minus 1 plus, and then plus another half x. So let's call this 49.5x. Cool. And then, of course, it's just a matter of plugging in your data, your boundaries there. Okay. I guess I'll get the calculator out. Someone's going to go down and tell on me, Mr. Groom was being lazy. Not that I really care. Go ahead and tell me. I don't care. Oh, you people think you seniors have it rough. Try teaching for this long. And then you try to get fired up every day. That's what I thought. Make sure you're in radians when you're playing this game. Wabs. I hope you all see this mistake right here. Did you see that? Did you? For God's sakes. That should be signed, Mr. Groom. You moron. How about you try integrating? This is what happens when you put off doing your homework until late at night on Sunday night before you have to go to work the next day. Such that x equals 7. That's Q. Such that x equals a goose egg. Hey, that's Q. So this feller minus this dude times pi. Whoop. 1113.58. What in the heck? Again, units cubed. Awesome sauce. All right, another one. We're on far now, friends. Yes, sirree, Bob. And how? You're thinking that's y, it's x equals square root of y. Or well, you're saying y equals square root of x. Wrong! X equals y squared. Wait a minute, isn't it the same function? It literally is, but this time we're going to wrap it that way, friends, which means we're chopping it this way. Yo, that means you got dy. So even if this was square root of x, you would have to convert that sucker to this because we want to integrate it with respect to y. See? And let's say we're going to go from 0 to 10. 0 to 10. So, of course, that's y to the 4th. So that's going to be y to the 5th over 5 pi. 0 to 10. 10 to the 5th power is 100,000. Last I checked. Divided by 5 is 20,000. 20,000 pi would be our answer. Units cubed. Boo freaking yeah. Alright? Now you're like, alright, do another one, Mr. M. I'm getting excited about these. These are good times. No, that's gross. I don't want to do that one. Yes, this will work. It's true. Scream, I want to wrap this region around the y-axis. No. Well. No, I don't. No, I don't. Let's do an easier one for the first one we do of these, okay? If that's okay with you? Because I know some of you are like, no, I'm pissed off at you now, Mr. Groom. Well, stick with me. You won't be as mad in a minute when you see how hard that other one was going to be. All right, I want to take this region here. I'd like to wrap it around the x-axis. That's what I'd like to do. So I'm going to get this dealio. And when you cut that off and look at it, what you're going to see is an inner radius and an outer radius, aka a washer. And you're like, well, Mr. How would I find this volume of this region? Well, I'd look at the area piece of it. So I'd say, well, it's pi times the outer radius squared minus outer radius squared minus pi times the inner radius squared. And you're right. It's literally how I do it too. So this function is literally going to be, so it's going to be f of the outside function, outside squared dx, and then from a to b, of course, minus pi, and then the inside function squared, inside dx. Bam! And this, friends, is how you do the washer method. So here's y equal x. Here's y equals square root x. Okay, well, it looks like square root of x is my outside function. And so that's going to be here. Let's go from 0 to 1, because that's where they intersect one another. The inside function is x squared. So it's x, so then you square it and get x squared. Duh. So square root of x squared is x, I believe, yes. From 0 to 1. And x squared's integrated is going to be pi x cubed over 3. So that's going to be 1 pi minus a third of pi is 2/3 of a pi. And 2/3 of a pi is always a good thing to have. Certainly better than having no pi. Okay, here's another. By George, I can't even think of one. I'm going to go to the great Desmos. Oh, great and glorious. Googly moogly. Nope, not Google, stupid. You want Desmos. Why do you hate me? Excuse me, friends. E to the, no, e to the x. That's what I wanted to say. Well, that's no bueno. I want that one. There you go. And I want x plus pho. What? And now, what I really like to do is I would like to integrate that thing. I would like to wrap this region that's bounded there by them. You see that region there? Do you see it? Do you see it? It's a pretty cute region in there. And it's bounded here, where they cross one another. Except that's not where they cross. They actually cross the other negative 3.981 part. So that's where they cross. And they also cross up here. Am I right? I feel like I am. So I'm going to wrap that around something. I'm going to wrap it around the line x equal 4. What? Mr. Grimm, are you saying that it's going to look like this? Well, probably that's what I'm saying. I probs am. I'm going to take this region here and I'm going to wrap it around this dealio so that it oh, I can't draw for sour apples. There it is. Cool. Now look, my inner radius is this dealio. And you're like, but I don't know what that deal is, Mr. Groom. Fortunately, I do. Okay? Now there's a bit of a problem with that. So after I said that, you can see there's an issue because Mr. Groom gave this to you in y equals, this was x plus 4, I think. So that's easy. I could solve for x there, no problem. But the other one was y equals e to the x, which of course could be rewritten as x equals ln of y, which is gross because that's not easy to it's not hard, but it's not easy either. So we'll talk about it. So this one's a little tricky, so I'm just going to, fair warning, x is ln of y is this function there. This is x equals y minus 4. That is this straight line over here. So this inner radius is going to be 4 minus that function because, look, it says x equals that, right? So if you want to tell me what the x is, I will tell you a y. You'll take the ln of it. Boom, piece of cake. So if your x is here at negative something, and I'm starting here and I want to know this radius, it's 4 minus whatever that is. So if that is a positive value, like up here, it's going to be like 4 minus 1, it's going to be a 3 radius. That's cool. But if it's negative over here, a negative x value, then it's going to be 4 minus a minus 4 plus. Okay? So my inner radius is going to be 4 minus ln of y squared. That is a gross, it's going to be a gross integral. Life goes on. Now for the outer one, it's going to be 4 minus y minus 4. And so it's going to be 4 minus y plus 4, which is 8 minus y. Am I right? I believe I am. Good for me. There we go. And where are you going to integrate from, Mr. Groom? Well, we're doing it from y's, and so we said our y's went from 0.019 to 5.749. So 0.019 to, gosh darn it, why don't you listen to yourself? 5.749. Okay. Okay, so we'll do the easy one first. So 8 minus y squared is going to be 16. What in the devil is going on here? Go away. 16 minus, no it's not, it's 64, you moron. 64 minus 16y plus y squared pi, oops, 0.019, 5.749er. Of course, dy pi 16 minus 8 ln of y minus plus ln of y squared dy. That's cool. So this one over here, of course, is going to be 64y minus 8y squared plus y cubed over 3. Now, I'm just going to put a big fat pi out in front of the whole shebang here, if that's aight with you. So, and then I'm going to find this value in here. I'm going to minus them, and then I'm going to evaluate the whole shooting match all at one time because I'm lazy, let's be honest. So it's going to be 16y, and then it's going to be, what's the antiderivative of ln of y? Well, turns out that it's ln of y, it's not, it's y ln of y minus y. Okay, I know that one off the top of my head. Oh, just a minute. I got to pause. That's annoying. Okay, there it is. 0.019, 5.749. Okay, so if you combine your y's, 64 minus 16 is 48y. Oh, dadgum you. These should be y's, you idiot. Moron. Alright, so there we go. Of course, none of the rest of that really combines, so that isn't really terribly helpful to me, but whatever. And then, of course, we got rid of that guy, so it's going to be minus and minus, going to be plus 8y ln of y, and then that was minus and minus here, right? So that became a positive 8, so then positive 8 times that's going to be negative 8y. So I guess we could have combined that over here and make this 40y. That's Q. And then here, it's going to be minus y ln of y squared. And then, of course, minus a minus, so plus 2 ln of y minus 2. Got it? Good. Didn't have to combine them. Could have waited till later. Whatevs. Just going to do it on the old calculator here. Mr. Groom, you cheated and integrated on a calculator. I did on that one, but the ones on your homework, you don't need to because they're easy. What about the ones in the test? Will they be hard? Probably. Well, you're a jerk. I've heard that before. Will we ever get to use our calculators? Yeah, some. But, we're going to learn how to do it the good way first. Oops. Doggone you. If you're going to use y's, stupid, then use y's and be consistent about it. Minus y times parentheses ln of y squared, right? Plus 2 ln y minus 2. Is that right? I think that's right, yo. Booyah. Now, give it the old such that y equals, what did I say, 5.49. Boom. 0.019. Boom. This fella minus this guy. Boom. Times 324. That's it, baby. Boom. Can't get it any easier than that, yo. That's just not very hard to do. Alright, I know you want to do one more. We'll do one more. Now this one's a little tricky. Mr. Groom, why are you being so mean to us? It's just what I do. It's what I do. So this is y equals -3. This is y equal x squared plus 1. I want to wrap this fella, you see. I would like to wrap this region here around this guy here. Well, Mr. Groom, that's going to give us an inner radius and an outer radius again. Yeah, I know. Well, the inner radius will just be 3 every time. You're right. It'll be 0 minus a minus 3. That's right. So I'm going to get 3 squared dx, because we're cutting it dx this time. I, and then I, x squared plus 1 squared dx. Beautiful. X to the foe plus 2x squared plus 1 dx. I. Oh, we didn't say we were going to. Let's go from 0 to foe. 0 to foe. No, let's do 0 to 2. I don't have to use a calc. That way I won't have to use a freaking calculator. Alright. Minus 9 pi dx. What do you mean, Mr. Groom? Well, this is just going to be an x, yo. And so, well, if you put in a 0 and a 2, it just gives you a 2. I know. I'm well aware of that. Minus 18 pi. Sure. Whatevs. So 32 fifths plus 16 thirds plus dos. I. This is 6.4 plus 5.333 plus 2. I minus 18 I. Uh-oh. We might have an issue. Maybe I should quit paying attention instead of quit. Maybe I should quit screwing around and pay attention. You all saw it, didn't you? Dadgum, you people. Why didn't you remind me of this? For God's sakes. It's this far from here to here. We went 3 more. Idiot. So this should have been x squared plus 1 minus a minus 3 squared. So it should have been a foe. Should have made this an 8. Made that a 16. Well, how did you know you're wrong? Well, because this is less than this, and we're trying to find volume. And you're not going to have a negative volume now, are you? No, I didn't think so. All right, let's see if Jay can not screw it up this time. My money's on he'll do it again wrong, because that's what he usually does. But let's try. You shouldn't be so hard on yourself. Why not? plus, that's going to be 8x cubicled over 3 plus 16x. That ought to do the trick, yo. That feels like it's going to be bigger than 18. That's going to be 32 fifths, which is 6.4 again. We already said that. That's 8 times 8 is 64. Divided by 3 is 21 and a third. That makes me happy. Plus 32. So you get 27, 59, 59.733333 minus 18, all times pi. 41.73 pi really ought to be your answer. So that's what we're going to be working on. The disc and washer method, very straightforward, very easy to do. It's nothing but pi r squared. All the ones on the homework, again, are ones that you can do with no calculator. Well, you don't need a stupid calculator, to do the integrals. We will probably do a little bit with the calculator at some point before the end of the year, and I'll let you use them a little bit.